Uh, I'd like to thank NASRC for allowing us to share some of our new technology with the audience. My name is Miguel Boskin. I'm with BITZER, and today I'm going to talk a little bit about capacity regulation improvements with CO2 compressors. Specifically, we will discuss the Veristep mechanical unloading for TE compressors with the CMRC, and go over some options for compressor selections with the Veristep and show the impact of adding Veristep to a compressor system. So a real world operation of refrigeration equipment really often leads to some challenging conditions for a compressor or a rack to operate. So this results sometimes in poor or difficult control for capacity regulation, or erratic compressor performance and possible damage to compressors by short cycling, wet operation, things that we all are familiar with that compressors do not like to experience. So one of the things we looked at was, in this case, and I apologize for the units being Celsius, but the idea would come across the same regardless. So this is a year's worth of data from a European city, and the black is the capacity requirement and the pink is the VFD speed. And those are two things I kind of want to focus on for to discuss, the Veristep and capacity regulation. So first of all, if you look up here, the VFD speed, about 50% of the time the compressor is running at 40 hertz or less. And that is a direct result of this next section here that shows that about 90% of the time, the capacity requirement in column 1 here is 50% or less of the actual design condition. So based on this information, this example, about 1% of the time, this system is running at its design condition, which is, shown up here at the top of this graph right here. So this makes proper, suction pressure control or temperature control and part load operation essential for a smooth running, efficient system. By BITZER's approach to trying to help customers improve this is trying to enhance capacity regulation for CO2 compressors. So what we want to do is offer as many options as possible to achieve a high degree of control at part load condition. So the introduction of the Veristep for our TE series compressors gives rack designers assistance in achieving these goals of reducing compressor cycling, minimizing capacity gaps, possibly cost reduction by eliminating other components or reducing the number of compressors on a rack, and mostly providing flexibility of having a second option, a second layer to what they have had in the past for capacity regulation on CO2 compressors. So this was the big driving force by BITZER R&D to come up with this solution for our customers. As I mentioned, the Veristep for CO2 is mechanical unloading, and mechanical unloading for CO2 is going to look similar to what we already do with HFCs. We would add unloader heads to the compressors, and then we control those unloader heads either by using an IQ module, which is the BITZER CMRC module, or it can be controlled independently without the IQ module. There are differences between the two options, though, and I'll go over that momentarily. So if you use the CMRC, which will become available with the TE series, you will be able to get down to 10% with a 4-cylinder compressor. Without the CMRC, you will be limited to step control and 50%. So that's still a option that was not available in the past because mechanical unloading wasn't an option. but the more technically advanced option would be the CMRC with the Veristep. So a couple notes, the unloaders that are shown on the screen are not backwards compatible with the TC series. There are some machining differences between the housings, so the Veristep will never be available for the TC series, but one option would be to replace a TC compressor with a TE compressor and add unloading to the TE compressor. As I discussed in the previous presentation, these are backwards compatible with the TC series. The Ecoline the Veristep available for Ecoline CO2 compressors are for all 4 and 6 cylinder compressors. So the 4 PTE to the 4 KTE are the small 4-cylinder bodies. They can have 2 heads of unloading. The JTE to the 4 CTE are also 4-cylinder, larger body compressors, and they as well can have 2 unloader heads on. And then the 6-cylinder compressors are our largest compressors. They are limited to 2 cylinders of 2 heads of unloading, which is different than our HFC version 6 cylinders, which can go down. We have 3 heads of unloading go down to 10%. So there are some slight differences between what you already may be familiar with our HFC Veristeps and the CO2 options. The U in this model number would be for the Ecoline Plus compressors with LSPM motors, and they as well can be used with Veristep and mechanical unloading. So this is the ultimate goal for additional options for capacity regulation. So in this slide, we're showing on the left a poorly balanced system. A poorly balanced system, we require a lower set point, suction set point, because of the high fluctuations in the suction pressure or temperature in this case. So the dotted line here on the left side is showing the reduced saturated suction temperature required to handle the high fluctuations in the suction pressure. On the right-hand side, a well-balanced system, because we have tighter control, we can raise the suction temperature of the system. By raising the suction temperature of the system, you have an opportunity to increase your system efficiency. So the higher the suction, and in turn, the lower the discharge pressure or temperatures, the more efficient your system becomes. So by adding additional options to to capacity regulation, in addition to the existing option of a VFD, we can further tighten up this system and get a higher SST to run at a higher efficiency throughout the year. So the next few slides, we're going to go over just some different options available, or how you may incorporate the Veristep into a rack selection. So I'm not, the information on the next few screens is not intended to be an exact real life example, but just an example of what could be done if you happen to have some of the conditions listed. So we'll use this as the baseline. So there are 4 same body size, same displacement compressors, which we're listing here as a pro. Right, you have one model number. It's easier for purchasing. It's easier for replacements, things like that. So the first one is a VFD, ranging from 25 to 70 hertz, 70 hertz being the max allowable for these compressors. Our capacity is 238,000 BTUs. That's the goal. So the fleet compressor at 59 hertz would achieve that capacity. The minimum capacity for this rack, based on an inverter only, is about 5% of the overall load. Because you can run these up to 70 hertz, means you can have a reserve capacity of 9%. We're listing this as a pro in this case as well, but you can also look at it as you're paying for 9% capacity you don't need, at least at the moment. So you're paying for a VFD, you're paying for a compressor that can up to 70 hertz, but you don't need to be at 70 hertz. So it can be a pro or a con. The most important one here is this capacity gap. So there are no capacity gaps between the minimum capacity of around 12 kBTUs up to the max capacity of 259 if you wanted to use all the capacity available. So that's a goal for designers, to reduce those capacity gaps so you don't have big jumps in capacities when you stage up and down throughout the year. So using this as a baseline, we can go on to the second scenario. So the second scenario basically eliminates the extra capacity that you had. So you're not buying an inverter or compressor that's not going to be used to its fullest capacity. It does reduce the minimum capacity down to 2%, but by doing those two things, you're introducing large capacity gaps between the stages of the compressor. So compressor number one with a VFD staging up to 70 hertz before it switches, slows down and adds compressor number two to the mix. So it's an option, probably not the best option. You can always add two VFDs, which would increase the cost. So a third option might be just to select completely different compressors. So again, you're eliminating capacity gaps right here. You don't have a very low minimum capacity, so it's not ideal. And you have reserve capacity, which again may or may not be a pro depending on how you look at it. So this option again isn't maybe the best, but there may be a combination that would work better. The fourth option is the one we're going to introduce Veristep to. So Veristep on the second compressor is an inexpensive way to add capacity regulation, in addition to having the VFD on the lead compressor. So now we have a very low ability to reach very low minimum capacities, because we can pick a smaller lead compressor and run it down to 25 hertz. We don't have any extra capacity, which again can be a pro or con depending on how you look at it, but basically you're not paying for extra capacity you won't use. And because of the addition of the Veristep on the second compressor, you can make up that capacity gap that existed previously by unloading the second compressor down to perhaps 10% and running the first compressor at 25 hertz or whatever hertz you need to eliminate that gap. So the addition of the CR or the Veristep to this really increases the options of how to make compressor selections, and it's a relatively inexpensive way to do capacity regulation. The last option here is just for a taste of what might come in the future is the addition of the LSPM motors. So the LSPM motor are higher efficiency motors. So you can perhaps reduce the number of compressors by adding unloading to both compressors, eliminating a VFD if the cost becomes an issue, but you also get a little bit more capacity displacement out of each LSPM motor compressor. So by the increased capacity you get for the compressor and the ability to unload basically down to 10 or 25%, you really have a nice smooth operation between min and max with the most efficient compressors that are available. So quick summary, I mean, the ultimate goal here is to provide the end users with equipment that can provide excellent temperature control and maintain the highest quality product quality for the consumer. So the last bullet on that line is really the goal, right? That's what our customers are looking for. That's what our customers want, is nice, high quality products. So Veristep allows for this in a cost-effective manner. It's not to replace the VFD. It can. The intention is not that. It's to enhance the ability of a rack designer to use more tools to finally provide a very high efficiency, well-controlled system at full load and at part load. And with the Veristep, we feel that the BITZER option really kind of solidify the ability to do this with many, many different applications and operating ranges and capacity ranges. Last is the contact information. You have some information on the screen here if you need additional information. In addition, there is a BITZER provides compressor training on the right-hand side. If you're interested, you can go to that link and register for the dates that are available in the times coming up this fall and the beginning of next year. So with that, I would like to thank again the NASRC for giving us this opportunity to share, and have a good day. Thank you.